Okay, so you've probably been hearing the term AI agent thrown around a lot lately. But what's really going on inside one, you know? How is it actually different from the chatbots we've all been using? Well, in this explainer, we're going to pop the hood and build a really clear mental model of how these autonomous systems actually work. Right off the bat, the biggest difference is the process. A standard AI, like your typical chatbot, works in a straight line. You give it an input, it gives you an output. Simple. But an agentic AI, it operates in a loop. It takes your input, but then it stops to interpret it, create a plan, act on that plan, and this is the crucial part, it verifies its own results before it even thinks about giving you an output. It's this continuous cycle of thinking, doing, and checking that changes everything. So here's our game plan. First, we'll look at the big jump from chatbots to agents. Then, we'll really dig into that thinking loop that gives them their power. After that, we'll uncover the two-layer blueprint that makes it all possible, watch an agent tackle a task from start to finish, and wrap up by understanding why agents are really more engineered than they are trained. So, first stop. Let's get our heads around this fundamental leap, the move from a system that just passively responds to you to one that has active autonomy. This is the core idea that everything else is built on. See, an agentic AI isn't just designed to answer a question. It's built to understand a goal. From there, it makes a multi-step plan, actually uses tools to get those steps done, and all the while it's checking its own work to make sure it's on the right track. It's this focus on achieving an objective that really defines what an agent is. So how does it actually do all that? Well, this brings us to the agent's internal thought process, that thinking loop we just mentioned. This is really the core mechanic that separates it from a standard language model just spitting out text. This loop always starts with interpreting the goal. What does the user really want to accomplish here? Then it plans out all the little substeps, kind of like a project manager. Next, it acts on that plan, using whatever tools it needs. And finally, here's the secret sauce. It verifies. It literally asks itself, did that work? Am I closer to my goal? Before it decides what to do next. This is the engine of its autonomy. Okay, so we've seen the process an agent follows, but what are the actual parts inside that make that process possible? Well, that brings us to the internal architecture, the blueprint. And the fundamental design is actually pretty elegant. You'll find that pretty much every advanced agent is built on this two-layer structure. Just think of it as one layer for what it can do, its capabilities, and another for what it should do, its intelligence. And here's a really great way to think about this. The first layer, the architectural one, that's the how. It's all about its capabilities, like being able to search the web or write code. Let's call this its tool belt. The second layer, the behavioral one, is the why. This is its intelligence, its ability to reason and make a plan. This is the brain that decides which tool to pull from the tool belt and when to use it. You absolutely need both to get anything meaningful done. All right, this is where it all comes together. We've talked about the thinking loop and the two-layer blueprint. Now, let's watch them work together in a practical, real-world example. This should be the aha moment. Here's the mission. We're not asking a simple question. We're giving it a whole project, research renewable energy, and write a 2-page summary. Now let's see what happens inside the agent's mind. First things first, the brain, that behavioral layer, gets to work. It doesn't just start Googling randomly. No, it creates a logical plan. It decides to define the scope, then search specific databases, identify the top 3 sources, pull out the key findings from each one, mash them together into a draft, and then format the final summary. This is pure strategy. Now, for each step in that awesome plan, the brain looks at its tool belt, the architectural layer. To search those databases, it grabs its web search tool. To read the reports it finds, it uses a PDF reader. It might even use a special text summarizer tool to pull out the important bits, and a document writer to put it all together. See? It's intelligently picking the right tool for each specific job. And remember that critical verification step? It's not just a final check at the end. The whole time, the agent is self-correcting. After finding sources, it's asking, are these really the best ones? While it's writing, it's checking. Am I staying on topic? Am I getting close to that 2-page limit? This constant feedback loop is what makes it so much more reliable than just a one-and-done answer. So let's zoom out for a second. Seeing this process in action really shines a light on the most important thing to know about agents. The real breakthrough here isn't just the AI model itself, it's the system that's built around it. You know, this requires a total shift in how we think. For the past couple of years, we've been obsessed with prompting a model, just trying to find the magic sequence of words to get one perfect output. But building an agent is about engineering a system. The focus shifts from the magic words to designing a reliable, repeatable process that can juggle multiple steps and tools to nail a complex goal. And that really brings us to the main takeaway here. The magic is in the design, not just the model. Yeah, a powerful language model is like the engine, but the carefully engineered system, the thinking loop, the tool belt, the self-checking, that's the vehicle that actually lets it go somewhere and get things done all on its own. And that leaves us with a final, pretty exciting thought. If the real power of these AI agents comes from how we design them as systems, well, the possibilities are kind of endless. It's not about what a model can be trained on anymore. It's about what kinds of autonomous systems we can dream up and engineer. So the real question is, what complex, real-world problems are we going to design them to solve next?